said in the beginning, it aims to be a superset of ES6, 7, 8, and all the other newer ECMAScript versions that keep coming along. So it's not an antithesis, it actually supplements and augments the ECMAScript language and specifications. Right, so this is an add function, and this is pure JavaScript. It is dynamically typed. I don't know what the values of A and B will be. If I supply two numbers, it's going to give me a number, right? Because it's actually adding them up. But if any of those things is a string, what will be the value there? String, right? Let's just, to convert any file to TypeScript, I'll just change the JS extension to TS, and it's now a valid TypeScript file. And it gives me some annotations by default. So I can see this, that it means that this is an add function, and it takes A and B, which can be of any types. I'm not constraining the kind of types that A and B can have, and therefore it's not able to determine the kind of types, the type of the return value that is going to give me. So it is also any, and this is what tells me. Let me add those types to it. So to do that, I'll just say this, and let's see what this tells us now. A and B are now numbers because I've told them to be so. And now the TypeScript compiler knows that the return type of this function can be a number and nothing else. Which also means that if I actually pass it two numbers and try to do an operation on the result, it's only going to show me, the editor is going to show me only the results that I can perform on a number. So I can use a two-fixed number to round it to however many digits or places. Okay, what happens if I try to pass this to my function? It complains. And what does it say? That 2 is not assignable to number. 2 is not a number. Right? Alright. So what if I were to write a function that took a number and a string? Again, the type inference will kick in, and it will tell me that A and B, when one of them is a string, return the string. Alright, so I can do similar stuff here, here. This is going to be a valid, this is going to compile. This basically means that it compiles. So if there are no errors in your editor, that means the file compiles and you are type safe. Okay, which also means I can do everything that strings let me do, which is a valid use case of a string. Okay. What if I add a plus here before B? This is a tricky question. What if I do this? Okay. It might be not a very commonly known thing, but it is the same thing as saying that B is a number. Adding plus or minus before a number in JavaScript magically converts it to a string. That's awesome, right? So this is no longer a string. This is a number, and again, only the string methods will apply. I didn't tell you how to get started with TypeScript, but that's very easy. You use yarn on NPM, you could use either. I go with yarn and just add TypeScript, and that brings you the latest versions. The current version is 2.42, 2.4.2, and that's generally all that you need to do. Once you have TypeScript installed, you can use the TSC command line tool to generate a tsconfig.json file which looks like this. And this has tons of options which you may use. I'll probably show you some of them here. So by the way, this is a single JSON configuration file that can replace all of your Babel configurations. You need nothing else, which is one of the best things I like about the TypeScript setup. I'll take you through some of them. So target is the kind of the down level target that you want to transpile your files to. So currently I have set it up to ES5, but I have all these options here. I could change it to ES 2016 or 17, and what that does is, in any case, whatever target I set it as, it will try to transpile it to the features that that specification of the language understands. So if I use features such as object.assign, which are not existent in ES 5 or below, it will complain if I don't have the polyfills for that language, for that feature available. I'll probably show you that in some time. Because I'm using it, sorry. Alright. So let me set this to ES 2016 or so. It doesn't really matter because most of the examples, I'm running most of the examples here on Node, and Node is fine with ES 6 or above. Module system is CommonJS is what we typically use. I don't want to get too deep into that, but this is the really important point. So I've selected ES 2016 and DOM as the kind of libraries I want to work with in my current project. But if I wanted to bring in features from, let's say, ES 2017, which was ratified very recently, like end of June, it gives me some amazing things. Let me roll this back. So concat is still a string, and I'm able to now use, let me just refresh. Yeah. These are the two functions that were recently introduced into ES 2017. So that is all. So you can choose what language features you want to use in your project, and it's just the flip of a switch, literally in the JSON file, tsconfig.json, and you can use those features there. All right. Let me move on to my next example, which is another simple one. Okay, simple add function. So, like I annotated my previous functions argument as number and string. Here's an example of how you can use more complicated ways of annotating your methods. So here I'm annotating it as an array of numbers. So in this case, values will be an array of numbers, and if I try to pass it anything else but an array of numbers, is going to complain. And this is simple again. I'm accepting all those values and I'm reducing them. So basically I'm finding the sum of all those numbers in that array of numbers. Alright, so you might notice that this is very similar to an add function, right? It is actually an add function like we wrote earlier. So I can replace it with this, but what happens is, yeah, wait, I think my editor has, yeah, it should. I need to export this function there, and the moment, okay, I want to show you this as well. The moment I change any file in my project, the TypeScript server kicks in and is intimately aware of my entire project structure. So, and because ES6 modules, which means these import and export statements, are statically analyzable, which means that the compiler is able to understand statically what is the shape of the objects that each module returns. So this adds enormously to the TypeScript experience. So because now I've exported my function, it offers to import it automatically from the other module, and here we have. And this is one of the very few features that TypeScript is able to provide you free of cost, because it has a very advanced language service that can work with any editors, that can give you this kind of experience, and there are lots of other quick fixes that I'll show you. And because it's embedded in the runtime itself, so I'm currently using Visual Studio Code, which is incidentally also written in TypeScript, but there are tons of other editors that rely on the same core language service, and therefore you're able to get most of these features in almost every other editor. But I think Visual Studio still has a good deal of edge over the others, because they kind of go hand in hand, and the development release cycle is also kind of together. Okay, so with that, I want to develop the motivation for interfaces. So we were working with primitive types like numbers and strings so far, but it is interfaces that really bring in a lot of value to the TypeScript experience. If you work with any other statically typed language like Java or C# or Scala before, you probably are aware of interfaces, I suppose, right? So I'll show you how interfaces look like here, and what are the features, how they can add enormous value to your JavaScript code. So here I have some kind of an object, and you could assume it probably came from some JSON response of an API query, and you know that kind of an API always returns this kind of shape of an object. So what you can do is, I have an interface defined like this. So an interface is a collection of other properties that define the shape of an object. So this post interface has all these properties, and it in turn has other interfaces that are available as an array. So here we have the post comment, which is an array, and both of these refer to this author interface. So all I need to do is, I can annotate this object as post because it looks very similar to it, right? Except that it does not, because there's a problem somewhere, and it says basically that body is missing in the type in my blog post object, and it is obvious because I have told my compiler that body is a string and it ought to be present in the post comment object, but it is not because it's commented out. So the moment I do that, the code compiles and everything works. Let me add some more functions to it. So just like with primitives before, you can have interfaces as function arguments, which looks like this. So I have given author as the argument type for getFullName function, and all it does is concatenates the first and the last names and returns that value back to me. The thing to note here is that from this point onwards, the moment you give it a type, the compiler is aware of the kind of operations that are possible on it before, just like before. So this thing gives you auto completion on every step of the way. Similarly, we have a get post comments count, which simply returns the length of the comments here. Let me define another object which also conforms to the post interface, and alright, and so I can add my objects in, let's say, an array, and the type and inference will automatically infer that these are two posts these are instances of posts that are stuffed in an array, and therefore the type of blog post will be a post array. So I have a function here that I wish to define that will get me the comments from all the posts in all these objects. So I can begin with this, that let me get the number of comments on each post, and then I can map it again, or rather I can reduce it now. And I can iteratively sum the number of comments on each post. So let's say I have an aggregator, I have a value, and again right? Does this make sense? Does this make sense? Okay, what I've done is, here are the two posts embedded in the blog posts. I'll use it here. The way you actually use it at call site is this. So I have this array of posts, right? I map over them, and I get the lengths of comments on each post. So it gives me a number, right? And this will return to me an array of numbers. So the result so far is an array of numbers, and that you can see over here, right? So I can take that array of numbers, and as before, like in the previous add-all example, I can reduce those to find the total number of comments across all these comments, all these posts. I'll show you how it actually works. I'm not kidding here. Okay, I haven't console logged it. Let me do that. What answer do you expect? 4? Because I have comments, 2 comments in each of these objects, so therefore it returns to me 4 as the answer. The point of this is that this is nothing new, of course. The point of all this is to show you that at every step of the way you are protected by the types. You have type safety at every step of the way. So the moment I do, let me write this again for you. Right? It is an array of posts. So the moment I map over it, what do I get? Posts. I get post objects inside it, right? Which is the type of this thing here. It says post. So the compiler actually knows what I'm working on presently. Okay, so which is why I know that post object has all these possibilities. The post object that I had defined earlier has all these properties on it. I could take this. The comments was an array, right? So it probably has the length function on it that gives you the number of items inside that array. If I get this, and then I can do whatever I did next, which is to reduce that value. Please feel free to ask me any questions if you have at this point. No? Nothing? Everything good? Alright. Okay. Like I had said, so I could replace this with a function that I had defined just above this. So I could use this here. And this, as we saw before, is the add function. I can again add it here and automatically import it to be present in my this module, and the result will of course still be the same. 4. Alright, so let me show you how to use these things in a real world example. This is a player interface that has first and last names, scores, and birthday of a player. And the examples I'm using is from the 1998 Sharjah Cup, which Tendulkar literally won us single-handedly the cup against Australia. The point of all this is that I have some functions on it, and type inference applies to all of them. So just believe me that all these files, if they're not showing any errors to you right now, that is because they're completely valid and I'm not making even a single mistake there. And that's the kind of guarantee and that's the kind of confidence that you can have if you're using TypeScript. Everything that I've shown you is still JavaScript, right? I've hardly introduced many new features of TypeScript to you yet, but already this is a great value and the kind of confidence is not easy to have. I'll show you what I mean by that. Probably I'll do that later, because the larger the code base, the more the values you start seeing coming from it. So I have methods here defined as full name, net score, age on that day. That match actually happened on the 24th of April, 98. That was Tendulkar's 25th birthday. And so this neatly collects all these details and prints the value here as the player's name, the player's age, and the total score. that he had in that tournament. So this comes out to be probably 435. All right, let me introduce another player here. You see, TypeScript is complaining to me about something. Let's see what it is. It says that string is not assignable to type date. And the reason for that is that in my player interface here, I've set birthday to be a date. Tendulkar complied with that, but Ganguly does not. Right? So there are two ways to fix it. Either I go back to change this and the interface itself, or I do something more interesting. I say that birthday can be both a string and a date. I'm not sure if you worked with languages other than Java or C# maybe, but there are some languages that allow this kind of behavior. This is called union types, and this is a very, very powerful type system. It basically is telling me that I'm letting the compiler know that my birthday could be a date or a string, right? Which of course is going to give you a lot more errors otherwise elsewhere. So here, I was assuming the birthday to be a date before this, but I can't anymore assume it. Right? It's right away telling me that getTime is the method that I'm using here. Does not exist on TypeScript on type string, because the compiler is not able to determine if what I passed it was a string or a date. So I need to tell it that specifically. I can do it in a number of ways. I might pass the date only specifically and then convert the string to a date before I pass it to this method. So let me try that. Each step of the way, there is an error to guide you what is the next problem. Right? So this method is now compiling fine, but there are errors here because the player here is no longer compatible with the birth date, or rather the date. So I need to change that as well. Let me change it in some other way. What is the method name I used? So I'm using this method like a helper function to figure out the type of the date before I pass it to this method. Okay, so, and this is also a very powerful feature that you get with these union types. So at the beginning, player.birthday is a string or a date. Can you all read this tooltip here? So because we've said that birthday can be a string or a date, so up to this point, before we've made any checks, player.birthday is indeed string or date. But the moment we actually check for this feature, we explicitly make that check if the birthday is a string. From this point onwards, in this branch, birthday has been narrowed down to a string. Right? If it is not a string, so what is it going to be here? Right? It is a date. I'm not sure what you're going through right now, but the first time I saw this, my mind was blown. And I'll show you some more examples of this later on. Alright, so over here I will just replace this function with get age with player. Yeah, it works. Everything compiles. That means that I've fixed all the bugs in my code, and I can just replace this with this function that will probably tell me the stats for Ganguly as well. Let me bring in yet another player to this mix. Okay, so there are some more issues here. It says birthday is missing entirely here. It's not just a matter of string or date anymore, it's entirely missing from this object. And this may happen, right? Especially if you're working with NoSQL databases, you have no fix on the schema. You may have historical data that may have been stored in other formats, or you may have even many columns missing, properties missing. And if you are working in JavaScript, or you need to account for all those things. And the goal here is to make our entire code type safe, because so that I can rely on the fact that when I say a player has a birthday, I ought to be convinced that it does indeed have a birthday. And step by step we are getting to the point where I can get that confidence. Alright, so birthday is missing entirely. TypeScript again has an amazing feature that lets you make properties optional. So if I just mark this with a question mark, that means now all those objects that conform to the player interface did not have a birthday. They may not have a birthday, which means that this is now perfect. And everything also seems to be perfect. So let me just add Kumble here, and everything should work as expected. Except it does not. And the reason for that is, you may not have noticed, but nobody has noticed, even JavaScript does not notice by default, that Kumble did not play the last two matches of that series. He did not get to that because Tendulkar stole the limelight. But because many languages are not null safe, which is why they give you null pointer exceptions. JavaScript, of course, being one of the more badly designed languages, would not be an exception. For this, TypeScript gives you a feature. It actually gives you tons of features to fix those things, but there's one single flag that dials the type checking strictness levels down to all the way up to 11, so to speak. And now this program is going to catch a lot more bugs than it ever did before. Right? Let's see what it says. Let me begin with the first bug itself. Okay. The moment I said strict is true, which means that one of the features in strict mode is strict null checks, is one of those flags. It's not going to let me assign anything to a value that it does not explicitly say that it is accepting nulls or undefineds. Okay, so the compiler itself will warn you whenever you're going to assign null to a string or to a number or to anything else that does not explicitly accept a null. Okay. So to fix this, again I'll go back to my original interface and I'll say that scores can be number or null. So it could be an array of numbers, or it could also contain nulls inside it. Alright, so the moment I say that, I should expect some more errors, because now it's literally the strictness level has increased and it's actually wants to ensure that I'm taking all the steps to verify that I'm taking care of all the nulls. I'm basically doing all my null checks. Okay, so the first error that it gives me is this, right? Because if I'm operating on an array of nulls, obviously my scores will be null, and I can't even do a null addition on that. I can't use a plus operator on that. To fix this, I'll first begin with the default initial value, which is 0, and because I'm beginning with the 0, so I can be sure that at least my aggregation value will be a number, because 0 is a number. So now I have to deal with score, which it says could be a number or a null. So that is simple. I'll just check if score is defined. If it is, I'll give it the value of score, otherwise I'll say 0. Right? That makes sense? Please feel free to just interrupt if you have any questions at all. Because the way I've structured this is that I'll be building upon these things as we go along. So we'll be using everything that we learned so far to go to wherever we are going next. Alright, so player.birthday also has a problem there. And of course it's expected because birthday is possibly not present anymore. And remember, we missed that check earlier. all these are new errors that we did not get without the null checks. So that's great. All I need to do therefore is to convince the compiler that this present branch can only contain a date, and therefore again when we were going into the branch, birthday was date or undefined because string has already been taken care of. But the moment I do this check, birthday is a date. For every other case, you could probably return a not available because the date was not available. And if we run this code now, it just works. I'll show you a more complicated or more involved example of the control flow analysis like this because it's really very interesting.
So is the player not birthday getting actually typecasted, or what is it? How do we get the date object and a string object?
Sorry, say that again.
So go back to your function.
Yeah.
Yeah, this one. So when you check if type of this thing is a string or not.
Yeah.
So this actually gave you player.birthday. Now it is a string, right?
Yeah.
So is the player.birthday again? Maybe I'm missing out something. So is it changing its behavior or no? What is it?
So there are two concepts here. TypeScript only adds static type, so it does not at all enforce any runtime checks. Okay, so this additional behavior that you're seeing here is the TypeScript compiler's awareness that at runtime this check is going to hold true.
So it is typecasted to it.
It infers, it's called narrowing down the type. So it's narrowed down the type from a number of options to the one that you have checked there for. But this thing is going to happen only at runtime. It's just the additional benefit that it knows that this kind of a check is going to narrow down your type, so it's able to assert that you are basically asserting yourself. Because you've written that code, so it knows that because you expect only strings to pass through in this block, so birthday is going to be a string.
Sorry, in that same thing, if on line 45 we added player.birthday and look for its type, it would be undefined or whatever, the last type remaining, right?
Exactly. I'll show you more examples of that kind here, which is really very interesting. So I could write this from scratch again, or maybe I'll just take you through it. So I have good combinations of stuff here. So this check function has an optional argument, which could be a string, or an array of strings, or it could be null. So basically, because optionals are undefined, so it could be undefined or null, or string, or an array of strings. So let's jog our knowledge of JavaScript a bit here. What do you think is going to happen in this block? What am I basically checking here? If arg means what?
Undefined.
Yeah.
Null.
Null or undefined? Anything else?
Null, undefined, both.
Sorry? Alright, let's see.
Empty array evaluates to falsy value.
Yeah.
It is false.
Yeah.
Amazing. And let's see how the TypeScript compiler knows that even if you did not know. So arg here is all these four possible combinations. And the moment I check if array, it is an array, right? Until this point it's string or string array. But the moment I check if it is an array, it is narrowed it down to argument of array of strings. And therefore I can use the join function here. So otherwise what would it be?
Tree.
Yeah, here it would be a string. Correct? Alright, if it did not go through this block, what would it be? And?
Empty array.
It could be a string. You know why? You just said it. An empty array is a falsy value. It's one of these oddities. So, alright. This one is simple. So, what do you expect here to be? Of course null, right? And this will be the rest, the other three. This one, Again, it's very simple. Undefined or the other three. How about this one? What would arg be here?
All string or string array. String undefined null.
Arrays are not objects.
Null is a object. String null undefined.
Sorry, say that again.
String or string array.
String or string array. Alright, let's see.
Null can be.
That's right. Somebody who said string array is correct, because in JavaScript, arrays, the type of array is object.
Oh,
But why is null there?
That is also an object.
That's a bug, but that's how it is. The type of null in JavaScript is an object. It's a bug that has not been fixed ever, because it can't be fixed because of probably backwards compatibility. But that's what we've got to live with. But thankfully, there's somebody who is keeping a watch and it tells you exactly what you're dealing with. So in the other cases,
Why is the string, like in the else part, like why is there is a string?
this string here,
Yes.
because we already tested if arg is an object, which means that takes care of null, the
So
bug.
string is also an object, isn't it?
No, string is not. We're not talking about Java here.
When you do new string, then it becomes object.
Okay.
When you use new keyword,
So string is a primitive type in JavaScript, and therefore you have string or undefined as. Okay, so anything else? Yeah, I guess no. Alright, I forgot to show you the class version of the player thing that we just did. So classes are of course just a syntactic sugar on the prototype. But they can be useful, and especially in this particular pattern, I find them to be really useful. What I do is, I give the constructor the type of an interface, and that saves me from, giving all these arguments in the constructor to construct my object. Does that make sense?
Yeah.
I'll show you what I'm trying to avoid here. Let's say I had this constructor function that was alternatively named as const. I would have to basically give all these things like this and then assign them here. But because of interfaces, we have a strongly typed way of doing this so that you can keep your shape and the methods that you operate on that object separately. So the class can be just the methods and the interface can define the shape. Everything else mostly remains the same, except that you now of course have to use this to access your player. And by the way, if you notice this is private. This is again a design time feature that TypeScript is able to give you. Of course, JavaScript has no notions of private yet. There is a proposal out there, but not yet not yet formalized. So which means that if I try to access this from an instance of player, I would not have access to it, as it works everywhere else in other languages. Like I said here, because of the way I've designed this, the moment I try to instantiate player, it gives you an autocomplete and all the kinds of things it can take. Right? It would be expected. And if I, again, as usual, if I try to give the birthday to be a number or something, it's going to complain. Okay. At the same time, like I was talking about the private, I only get access to all the methods that I've defined on this class and nothing else. The result of this is also exactly the same as before. Alright, I have some examples from Redux, but I'll take them only if people have some experience with it. Have you worked with Redux? No? You have? Okay, what I wanted to basically show was, even if you do not know what it is, it does not really matter, because over here I'm just trying to show off some language features where you can use TypeScript to great advantage. So so I have some interfaces defined here and some enums. So this adds a lot of flexibility, especially in Redux code, because there's a lot of boilerplate involved where you have to name your action types with strings, right? And then you have to ensure that you check on the same strings everywhere. You can use it to a great advantage here. Alright, so let's see, I have to use this, no, not really here, but in one of the reducers actually. Yeah. So, yeah. So I have constrained my action to be of this type, of action type. You, without understanding of Redux, let me try to simplify it further down. Basically, a reducer function is a function that takes, it's a pure function firstly, so it does not have any side effects. And it takes some arguments and returns a new state of the object that it was operating upon. Okay. So the real thing that I wanted to show here was the intersection type. So earlier I showed you union types, right, which is like a union of a number of different kinds of types or interfaces. This has also the concept of intersection types, which means that if I have two interfaces, I can place an AND before them, and then the resulting action will have the type signatures of both those kinds of interfaces. So some of them are from I to do, and the last two are, and the last one is from I action. So the properties of both the interfaces will be available to me here. And the other thing that I showed you was enums, which comes in really very handy when you're writing these things. So for instance, yeah, these are basically I'm trying to constrain my my action is the no, where am I using this? Yeah. Okay.
Excuse me. Is there any relation between that reduce function and Redux? That reduce we have used, right?
Yeah.
Any relation between Redux and reduce?
Yes, so that is how it works. So Redux is all about, it's a single object, huge object of state, right? Typically in your React application, but I think you can use it with any other front-end framework as well. And you are only allowed to perform atomic operations that can change only a bit of that huge state tree and return to you a new state tree. So it is an immutable operation on that object, and this operation is typically called reduction in Redux terminology. That's where it got its name from.
I think he was asking about the reduce function which you have shown it earlier.
Oh, that reduce?
Yes.
Oh, that. Oh, that is reduce is a function available to any array actually. So even if you do not know the operations available on any type here, you can see that an array gives you all these methods on it, and reduce is one of them. If you work with a language that has fold on it, I'm not sure. Have you used map earlier?
Yeah, sure.
Yeah, so map and reduce generally go hand in hand. You generally, map collects stuff and then you want to provide, reduce them down to a final value that is some operation and all those things. So typically they operate on arrays, which is why it's available on the arrays.
Prashant, about that I action and I state, you mentioned about that it will be intersection, correct?
Yeah.
The action will be intersection.
Yes.
But when you are showing like actions, so you have shown that okay, it has a 4 action types like
Yeah.
properties.
Yeah.
3 were from the I action and 1 was from the I state.
Yeah.
Isn't that a union or it's an intersection? Because intersection means the common things, isn't it? From the
Okay.
both.
You're talking about the set theory.
Yes.
So it is the common thing, right?
It was the common thing.
Yeah. So the union meant that the pipe operator means that I have to choose between one type or the other at runtime.
Okay.
So in intersections we have both the properties of both interfaces present,
Mhm.
and in unions you have property of one of them present but not both. It is an either or versus and.
Well, set theory actually union is a combination of
Combination of that.
In type theory, I know that's kind of confusing. In type theory, this is what they call it.
Because that's a union means it will be from both. Like, and the intersection means it will be common. Like if you have a 4 elements and 2 are common, in intersection you will get only 2 things, not the 4. That's what.
I don't know. I haven't studied the mathematical type theory in a long time, but this is how they call it in type theory
Okay.
over here.
Actually, it's A union B minus A intersection B.
Okay. Okay, I guess, yeah, generics, which is my second most favorite feature after interfaces, and almost everything that I'm going to show you after this is based on generics. So get this right. A very simple example again. This is a simple map in JavaScript or TypeScript. I'm able to give it any values. You are aware of maps, right? It was also introduced in ES6. So key value pairs, and the key could be something and the value could be something else. You can organize them accordingly and expect, you can use them in your applications, expecting that if you get the key, if you get on the key, you will get the value that's associated with it. Over here to this map, I could do the other thing as well. No, what I meant to do was, yeah, or this. Basically, there's no type checking going on here, which means that I'll have a rough time handling this in my code because I wouldn't know what to expect here. So probably I'll be doing my type checks. I'll be checking if the type of this is this or that, or as you may expect, I can give it the kind of types that I want to restrict it with. This tells me that this map is a key value pair from a number to a string, right? It's a common feature in other languages. Java, of course, has it. So the moment you do that, this starts failing, and for obvious reason, because the string 2 is not. Of course, this would work. Or not. It's actually the second thing that is a problem, right? Oh no. Wait. This would work. Anyway, the point is that this is what's called generics, generic programming, and it lets you templatize the kind of properties that you're going to use in your function or in your class. So I'll show you another example which is of sets. So you can also have a set that can only take numbers, and then you can add to that set, but you can only add numbers. So this is right, this is not right. Alright, so I'll show you how to write one such generic class in TypeScript. So the typical notation you use for templatizing is D. So what I'm saying here is that I have a class, simple set. It's basically a smaller subset of the set that we just saw with about 3 or 4 methods on it. I'm saying that at design time, I'm saying that it's going to operate on the type T, which I'll define when I'm actually instantiating this simple set. So I say that is a T, and then I can operate on that T everywhere and return it wherever required. And I'll show you how it works in actual practice. So here I have a set, simple set, that I've instantiated with the type of employee, and the employee interface looks something like this. It can have a name and an ID. So the moment I instantiate the simple set with an employee, I can only add instances of employees here. Right? How does this sound? Is it exciting that you can do this in JavaScript? So from that point onwards, I can assume that players have been instantiated with only employees, and I can do everything that is possible on employees. So if I right? If I, for instance, if I have a get method here, I do not have. I do. Okay, values. Values is an array, so I cannot get the first item on this. And on that, because it's an employee, so the properties of the employee interface are available. Okay. Probably take that. Alright, yeah. I'll probably show you an example from React. So the way React works in TypeScript, it relies heavily on generics, and this is where it uses them. So I have two interfaces defined called props and state. You can imagine what they mean. You work with React before, at least have some idea of React. How many? Good deal, I guess. Alright. So should I explain what React is about, or should I just go to language features? Language features, right? I guess. Cool. I think I should show you before that. So far we've been working only in TypeScript land, and of course that's not a day-to-day situation. You probably will be working with tons of other third-party libraries that exist on NPM before, which were not originally written in TypeScript. So you need to bridge that gap, because over here, as you can see, when I say React, all the functions that are available to React are available to me. So where did all this come from? Right? So this is a testament to the enormous, an amazingly large ecosystem of TypeScript, because it's been around for a long time. There's a concept of type definitions, which means that even libraries or frameworks even that were not originally written in TypeScript can be given a skeleton of the API they expose, which means that I can write definition files, type definition files that explain to me the shape of the public API of that library. So if I am talking about React, for instance, React object has something like a component, right? So, and then component also has some kind of a shape. It has some methods available on it, some properties available on it. And even if that original library was not written in TypeScript, like we have seen all the examples here, you can write something that's called a type definition file, which will let you use it in your TypeScript code as of today. So I'll show you an example of what that means. And to install one such type definition file is very easy, because it's been namespaced with the @types npm org, which means that if you wanted to install the type definition file of React, like I've done here, you would do this. You would first probably install React itself, and then get this thing here, which basically means that bring me React, and also pull down the type definition for React. What that looks like is present in my node modules. And this is an example of a type definition file. You probably would not know that the React API is so huge. But this file exactly describes how React is shaped internally. And this is something that's a lot of community effort has gone into it. So people who may be using these third-party libraries in their TypeScript projects have come up with them, and they have constantly try to keep them up to date with the latest releases. So I'll show you what this can do to you. I just showed you how when you write a React component, all these things are available to you thanks to that type definition file which I have installed in my workspace. So these are all available, and the methods that this can take are also available, like I showed you already, and their type signatures are also available. So React has one of these methods like should component update, which takes what? Right? Should not. Okay. What is the problem here? All right. Yeah, it returns a boolean, right? So I think it's complaining because this method is not returning the type that it should return. Okay, does not take. I'm forgetting this. Does it not take an argument? Okay. Sorry. So it could probably be another method like will receive props probably. Okay. This is a newer feature that is able to pull down even the methods available to a class. So it's probably not yet smart enough to know the kind of arguments it's going to take, but it knows the return type of these things, and these are all defined in a type definition file. So if I go to react.component, it's going to actually take me to this definition file where the interface is defined. You don't have to worry about all this. You just consume these things and carry on with life as usual. Okay. The other things that I really want to show you about React in specific is that so I mentioned generics a while ago, and these are the two interfaces that are defined. And the first, so React.component takes an optional generic value, which tells it the kind of state and props the shape of the state and props is going to have. Okay, so I have said that these interfaces are the shapes, and therefore this point onwards, whenever I do, for instance, this dot props, it's actually going to suggest to me the shape of the props object. And as before, some of these could be optional because interfaces are optional types. I'll show you what exactly that means at call site. So I have this component basically takes takes some values of, what are these values? These are values of strings, okay? So it takes in an array of strings and renders them in a list. So the top component renders the UL, and the list item component renders the LIs, okay? And because I'm telling you that this is type safe, I'll show you what that means. So list item has a certain interface because it accepts some props, and if I don't satisfy that interface where I'm using this, it's going to complain. And what is it? What is the complaint? It says that value is missing in this here, which means that I better supply the value prop which my component expects. I have also some other props here which are optional, therefore they're not being, it's not complaining about them, but I could probably say this. And if I try to give it a wrong value, of course it's going to complain again. Does this make sense? Yeah? No? Not much? Okay. I'll probably go out of React because it is a very specific example, and I want to address specifically the concern that TypeScript is only for Angular, and I wanted to bust that myth, which is why I took this example. By the way, because we have React's type definition, so we also have some properties here. And is anybody here a fan of writing inline styles in React components? Right? There's a philosophical debate over it, but I'll show you how you can do that more easily inside with TypeScript as well. So I have this React.css properties interface which gives me certain values. Okay, it's not a complete list, but it has most of the stuff, and therefore it lets me autocomplete on the CSS styles also that are available to me. And of course, together with their, I don't know, it's probably going to be true or whatever. I don't know what this is, but it's not an acceptable value. So it's actually type checking for these items as well. This is a very primitive way of doing it. There are much better libraries that are written in TypeScript, and they let you use CSS inline and they give you probably the entire set of CSS properties that are available, and they let you type check your CSS in JS code as well. What else did I have to show you here? I guess that is it. Okay, everybody is aware of promises, right? That's something that's really very cool. I hope nobody is writing their callbacks anymore, as far as possible. I'll show you an example here where I'm trying to bring in TypeScript to help you probably do this. I'm going to drive what is called type-driven development, which is possible to extend, which means that I'm trying to use the type system that I have to arrive at the code that I expect, and therefore kind of a solution, at least the skeleton of a solution. So I have a node program here, okay, read file, and okay, so this is another thing that I wanted to show you. So because the node's type definition file is present currently in my project, so it is exactly aware of where the read file definition is present. Read file is present in the FS module in Node. Okay, so it just imported it for me, and okay, I don't want to use this right now, but I'll probably do that as well. Okay, and okay, so what this does is it reads the package.json file and it writes it back to the console. Let's see how this works. That's expected, right? The thing about this is it's a callback style. The error first callback style, right? Are you aware? I hope you've used enough of Node, and especially IO in Node. You will probably aware of the fact that Node uses the callback pattern that it uses has the error first and then the data, which looks like this. It's an arrow function here, which gives me the error if there is one, or otherwise the data, right? But this is callbacks, and we want to get rid of callbacks. So there's of course the other method here. Instead of read file, you use the read file sync, which is terrible and you should never use it, but I'll just show you it works exactly the same way, except that it is a blocking system call. So because this is the synchronous version of the read file method, so everything stops, comes to a standstill before the file is read, and after this only the control will pass to the next line. Node is one of the first stacks to have asynchronous I/O, and a very good implementation of asynchronous I/O, and you should always try to use that. But of course this reads so simple, right, isn't it? Should not need to do all this, and let's explore if there is a way to do this using promises. So this is a small exercise in functional programming. So basically what I want to do is, let me read it maybe. Let me pass it some file name, and what my hypothetical reader should be able to do is, it should be able to read this file asynchronously, pass it some values, or yeah, right? Get this value here, and you should be able to console log it, right? And I want this operation to be async, not synchronous like here. So let's define a function here. The first thing I want to do is I want to show you this thing here. What is it? Okay. Have you used async and await yet in your projects? Yeah. So what I want to do is first promisify this, and then I will await on the result of that promise, right? and that will be possibly a string, because it's a string of the file has strings in UDF-8, and I want to output that. Okay, so let's start defining that function, how it might look like. Read file async. It should take a function, right? Because I'm trying to.
Can you please increase the font size?
Sure. Is this better?
Yeah.
I think I'm missing something here, so I'll go to the other. Oh yeah, I want to discuss this function here first. Let me just quickly take a look at this. That's why, that's the missing piece in my puzzle, I guess. So I'll just write again for you. So I want to write a function that sleeps for, I just want to basically develop the motivation for await and how you can use it in your programs even today. I want to write a function that let's pauses the execution for some time that I specify before continuing, right? And that kind of thing is very hard to achieve using callbacks. I mean, you of course you'll use set timeout. Of course, somewhere down there you'll have to set timeouts. But then you'll have to, once you start using callbacks, you have to inline everything in callbacks, and that's what callback hell is about. So I'll show you a way, and let's go there together, in which I can let my program sleep for a while, for some duration, and then it will resume its operation wherever it left off. It seems that promises are an excellent way of modeling this. So you can have a promise which the sleep function returns, which is why I'm able to await on it. The promise takes two arguments, right? Which ones?
Resolve, reject.
Yeah, right. Resolve and reject. So resolve is called when the promise resolve basically succeeds, and reject is called whenever there is an error there. Over here we only need the resolve callback. So what can I do here? I want something to resolve after a certain time. What should I be using? Set timeout in some form and shape. Let's do this. Right? What will be the predicate that I give it? What should I pass it here? Sorry?
Console.log and
Sorry, say that again.
console.log.
Console.log. Over here. Okay, I want the promise to be resolved after so many seconds. So yes, I will call the resolve function whenever the timeout is up, and then I can just give it this. Does this make sense? Let me know if it does not. Yes? No? I can repeat it again, no problem. Alright, so I'm assuming that it does make sense. So what does this let us do? Firstly, what will the result of this function if I call test here? Right, expected. What would this give us now?
Hello world.
Is it? Let's see.
Hello world कर दिया.
No. Hello world is still printed together. So there was no pause between hello and world. It does pause when I add the await here. And please note that this is an async function, which is why it is able to await inside it. If I use await in a function that is not async, that's an error, and TypeScript will warn you. Okay. So the moment I do this, it pauses for 2 seconds and gives me that output. Okay. What do you think will happen if I say first, last? What will be the output here?
First,
Last. Hello world.
Yeah, that's right. it still pauses for 2 seconds. But do you realize the amazing thing that await is letting you do? And you know what await looks like in JavaScript? Okay, I'll show you that, what I mean by that. I have the TypeScript playground here. I have a regular function, check, whatever. Doesn't matter what is inside it. And this transpiles my code. I haven't shown you the transpilation part, probably I'll show you a little later. Okay, so far it looks good. I like. In fact, I could even write this as an ES6 fat arrow function and it will still resort to the same function here, right? Except it's in function expression here. What happens if I add async here? You know the amount of code that TypeScript adds to async? Look at that. That's the amount of work it's actually doing on your behalf, so you can write code like this. And it's amazing. I'm not sure if we have enough time, but I wanted to show you how this works in the browser as well, and it's amazing. Should I?
Yes.
Alright, I'll show you a real world example of how that can help you. Okay, so let me quickly say this. Alright, this needs to be much bigger. Windows. Visible, right? So what it does is just increment that number whenever I click it. Okay. Let me add something else going on here. Let me add a for loop. Less than, I don't know, 1,000, 10,000. What's going to happen now? If I refresh it,
It takes some.
alright, it did it very fast. It did not really show up. Add one more zero to it. Refresh it. I'm not even able to click it. Right? You understand why?
So blocking on.
Yes, it's a blocking code. And JavaScript is single threaded. So everything is blocked until that loop finishes. Let me just introduce that sleep function here. Alright, this is HTML, so it doesn't know what this means. I'll just make it sleep for some time. It could be even 0 actually. And alright, what I need to do is, because I need to await on it, so I need to enclose it inside an async function. So let me do that. Count maybe. Now I can await on it. And yeah, does this look good? What I'm trying to do is, before each iteration, I'm trying to just put the thread, basically add a timer so that the thread goes to the event loop while I can do other stuff. And look at this. Oh no, it's not yet counting because I've not yet started the counter. Alright. It gives it enough time for everything to resume. And I think this is an amazing way to make your computation heavy tasks in the browser still not lag. Okay. I have tons more examples, so I don't know how far you're willing to go. Yeah.
You wrote that you are putting the thread to sleep, right?
Yeah.
So, means I didn't understand how it's going to sleep. Like, is it going to sleep just for the for loop, or will you pause the entire execution because you're still able to click? So,
Yeah.
I mean, like,
Right.
thread is want to sleep, so you should not be even allowed to click.
Exactly. It's a great question, and I'll tell you why. That's the very nature of how await works. So the moment that's why the requirement is that you need to put these things in a function that is explicitly async. So the moment you do that, everything inside this async function only will block whenever you await on something. It's only this part of the thing that is actually blocking.
So async function ensures that the sleep is put only on that part.
Yeah, and in fact everything here will be in the order, like we said, like we saw in the hello world example. But everything other than this, outside that async function will continue as usual. Okay, so are you willing to go on, or I have a lot more examples to show. So these are some of the exciting things even about Node and JavaScript that really interest me a lot. So I'm trying to show those things off with the help of TypeScript. So we should go on for a bit more.
Yeah.
Yeah?
Yeah.
Unanimously? Okay. I wanted to show you a bit of functional programming, like I said. I wanted to show you what type-driven design could look like in principle, although we don't really get to do it as completely as possible. So, okay, so let me know if any part of this does not make sense to you. What I am expecting here is, I think there's a problem somewhere. Okay, yeah. So I want to create a method. Yeah, I want to basically create a promisify function, which will let me, replace all my callback functions with promises. Okay. So what that might look like again is, I want to promisify in this case the read file function from the FS module. Have people worked here on Node? Are you aware of some things about Node? Okay, so just JavaScript on the server, but gives you an amazing advantage that you can use the same language on both the server and the client. So I want my method to look something like this, and which will let me await on it. Okay, so let me go backwards. Once I have basically described what I want the final thing to look like, I'm going backwards, and then I'll write my promisify function. So it will be a function. What will it take? So read file is a function itself, right? So it will probably take a function. And what will be the arguments of that function? It could be basically anything, because I'm writing a generic promisify function. Generic in the sense of general, not the templating generic. So the way you do that is, you can use these things. Is it the rest operator or the spread operator? I always confuse it. Yeah, the spread operator. Yeah, it spreads basically the arguments, and I'm able to tell it that the arguments I have to give it a type again, because it is a TypeScript. So the best I can say is that it can be of any types and not necessarily of a particular string or a number type, right? So, and what will be the result of this? What is the result of read file? It basically returns nothing to me, because it relies on callbacks. So this part of the program is so far fine. Okay. Okay, so this is a function that returns something, right? And what does it return? It returns another function, because I'll be using that function later on. So this is a bit of mind-bending functional programming. If you're not used to it before, it may look a little odd. Just bear with me and we'll arrive at a solution. But please do feel free to ask questions as before. Okay, so this is a function that returns a function which will look like this, right? So it will have scope of accept, it will probably accept some more arguments, again of any types at all. So let me do that. It will have some other arguments, let's say again of any type, right? And what does this do? It returns the execution of the function that we passed it, read file, with the arguments we give it here. What we basically want is read file which has been given these arguments, which would then look like something like this. Making sense? No? No? I'll repeat it if you do not get it. Okay, cool. Let me scratch this whole thing back. Or rather, let me leave it up to this point. Okay, so what I intend to do is, basically I want to remove the need to use callbacks in my I/O operations and still make them look like I'm doing a sync operation, but actually have them to be async, right? So I want to be able to write my methods like this. And of course, because I'm using a wait here, so you may expect that I need the async here, which will shut up TypeScript on another count. So this is what I want, and I want to therefore define the promisify function, which will return a promisified version of my read file. Okay? So I'm working it backwards and basically driving the motivation for how you can use static typing to your advantage. Okay, so here is a promisifier function. And what does it do? This will return a function that I want to be able to call later on, right? So this is a function that will return a function. Make sense? So it will be something of this kind, right? And this function also will return something, which is what? Something, let's just say anything whatsoever. It could be anything because it's a generic function that we're trying to write. Rather, this is wrong. I don't know, maybe this, or rather no, this should be a promise because I'm awaiting on it, right? So this should actually return a promise. I could for the moment just say promise dot resolve. Okay. Now we need to fill in the gaps so that we make everything to compile. Okay, so read file is the first argument, or rather the name of the function is the first argument to the promisify function. So this will be satisfied if we give it the signature of the read file method, right? How does read file look like? In its definition from the type definition file, it looks like it has a number of arguments followed by that callback function which we want to replace, right? Okay, so basically we can type it as this way. Does this make sense? No? Yes, right? So this is a function, call it anything whatsoever, doesn't matter. And this is an argument here to this function, and it has a signature of this kind. It takes some number of arguments. It doesn't matter what they are, because here I don't care what specific function I'm trying to replace, because I'm trying to write a generic function. Okay? So it takes any number of arguments and returns a void because these functions do not return anything themselves because they rely on the callback. So this is fine so far. Now we need to deal with this part. Okay? So it's obvious that because the result of promisify is something that we are able to call back, right? Because this is a function invocation again. So the response to this is also going to be a function, which is why we have it this way. Right? It's a function. And what will be the arguments that this function takes? Strings, right? Or basically anything that the function that you're trying to promisify will take. So because we do not know that type, so we can again type them kind of arbitrarily and say they are of any type, right? So far everything looks good. Everything looks good so far, but now is when we need to also resolve the promise. We need to basically implement this now, right? So far I've just relied on a random promise, but I need to implement this here. So let's go to the implementation. Okay. What I need to do is return a promise, so it will probably still look something like this. Yes, it will have the two functions, resolve and reject, right? And what will this do? What should this do? Sorry? Yeah, I'm hearing the right sounds. Exactly, right. So it is now that I need to call this original function that I passed it here, which will be this or something else. I want to call it now, and what will I call it with? Sorry? I need to pass it the arguments like this, right? So ultimately we are at this stage. We have finally reached the actual invocation of the function, because somebody still needs to do it in the callback style, but make it promisify. So we are here. So what will be the arguments here? This one?
Yes.
That's right. So we can just pass the fn args here. And what next? There's a callback to deal with, right? So what do we do?
Resolve.
Yeah, we need to resolve that, right?
Resolve it.
So because error is the first one, so let's type it out here. And let's say the result of that could be anything at all, doesn't matter. Now we need to resolve it. So if error occurred, actually I can write it in line as well. Error occurred, what do we do? Reject. Yes. And otherwise?
Resolve.
Does this make sense? Shall we try it on our program? Let me see if I have. Yeah, I have shut it down and it still works. Is this amazing? You just did away with the callbacks entirely. And you can use this promisify function that you've created for anything else entirely. Maybe I'll show you another instance. Read directory. This is also an async method that relies on callbacks. Let me make read dir async, promisify it. Yeah. And just call it here. In fact, I don't even need to do that. I could just await directly inside the console log and give it the root path wherever I am. What this does is it gives me a list of files that are there in that root path of mine. As simple as this. All my callbacks are gone. You could add a mix to this, you could add some generics to this. How would you do that? If you've been following so far, tell me how we can make it generic, this promisify function. What would you need to do?
Unionize it.
Sorry?
Make it unionized.
Templatize. Okay. So let me add the template T here. What do we do with it? this what we need to replace? The result will be of that type. Which means that in this case I can say that it returns a string, and in this case it returns an array of strings. So if I were to actually see the value that it has, no. I think I missed the type. Okay, yeah, I know where. Resolve, reject, result is this. Yeah, the reason for that is, okay, here. You have to annotate your promises like this. And now it should have fixed it. String of array of strings. Right? So once you have this, you can do everything else with your arrays. This program is not completely typeset. And you can get one of those values here, and you know that's a string. You can do uppercase it as before, as always. I have more examples. I have design examples. Would you want to go through them? Or is it too late? I think it's late.
Too late.
Next session.
Yeah. Was this helpful?
Yes.
There's a lot. I would have really liked to show you. Maybe I'll just show you quickly, because that really adds a lot of value to your work, to my work at least, and that shows you the full power of what you can achieve with TypeScript and with interfaces and generics. So I'll just show you examples. I won't write anything down anymore because I have all the code ready. I have, can I make this a little smaller? Is it still visible? No? No. Alright, no problem. Okay, so I have a basic. So are you aware with the concept of isomorphic or universal JavaScript? Because of frameworks, libraries and frameworks like React, and because Node is also available, you are able to reuse most of your code from the client on the server and vice versa, which is the great promise of JavaScript, right? Because you can use the same language on both your client and server, which also means that you can abstract out a lot of this code, which can reuse everywhere on the server and the client. And I think TypeScript really helps you a lot to get there, because it is statically typed. So what I've done in some previous projects is I have taken out the common functionality, which is, for instance, models, right? You're reading from your database and you want to store that into a model, which you want to send down the wire as JSON. And once you are on the client side, you use Ajax to get that value back, and then you can serialize it back from string to the object, and you would expect to be able to serialize it back into the same model that you had on the server, right? This is possible. And because of static typing, you can technically even have methods to serialize and deserialize these things back, and place this common chunk of code in some other repository which both the server and the client can depend on. This is a lot of power that JavaScript and only JavaScript can give you. I have a small instance of this program that kind of builds upon that fact, the fact that you can share your code. At the same time, it also exposes some design issues that are not easy to address in JavaScript land that you can do inside of TypeScript because of interfaces, especially interfaces. So I have a piece of code here. It's a controller. It has a typical CRUD methods. It has some serialized methods, and it's trying to set to session storage and read back from session storage. Firstly, I would want to know if you feel there's anything wrong with this piece of code, anything about the design or anything at all. This works, not that it doesn't work, but there are some problems with it. Can you identify them? Is it good that I depend on session storage directly?
No, it can be available only in client.
It may not be available, right? And what if I want to reuse this controller somewhere else as well, which is not the browser at all? So you have two options, two possibilities. It may not even be available because you're not in the browser environment. You may be in the node environment. Or session storage itself may not be available in the browser. It may be disabled, which is possible to do. Or if, for instance, if you browse Safari in private mode, session storage is not available. But I'm depending on it, and if it's not available, this program is going to crash. I've also put lots of low-level logic, reading from session storage and throwing this error right here into my controller, which is not probably the right place to do it. I've also constrained myself to a singular implementation of the serialize and deserialize methods. And there are ways in which you may not want this to be so. Especially if you want to make this portable, this controller thing, you may want to use other logic for serializing and deserializing. So let me show you how it can be improved. I have defined a few interfaces because interfaces is key. I'm depending on the concrete implementation of storage because that is all available to me in JavaScript. The notion of interfaces technically exists, but it's not really possible. I mean, interfaces are only objects. What I've done here is, instead of relying on concrete implementations, I'm trying to rely on interfaces, which is always the recommended way of programming in any language at all. So I have this player interface, the object itself, the shape of the object is player and it looks like this, as before. I have a controller interface that has my typical CRUD operations. I accept an object of type T and I read back the same type T. I also have two interfaces that are serializable and deserializable. So any controller of mine should, instead of defining its own serializer, could probably depend on an implementation of serializer that's been given to it. I'll show you how. And then lastly, it is this interface, which is the storage provider. A typical, again, CRUD operation that you can do on any storage service. Right? Save, get, update, and delete. With all these things, this is how I've rewritten my player controller. I have this player controller which implements the controller, which accepts the type of player. It is deserializable to it serializes player and deserializes player. So instead of relying on concrete implementation of the storage, what I'm doing is I'm actually constructing it. I'm inverting the dependency and I'm giving it storage provider in its constructor. So this is the storage provider constructor, which I can then expect to be able to call my save, update, and all the other methods on. Make sense? Make sense, right? At the same time, I also have deserialize and serialize, which I've not implemented here. But I still try to bring in their implementation at runtime. And I'll show you that in just a minute. So far, it doesn't make sense. I'm no longer dependent on a specific type of storage. Right? I'm dependent on an interface that will give me all the other methods that are available to any storage provider. Okay, so here is an example of one implementation of the storage provider. So I have a session storage provider that implements all these methods that storage provider is supposed to have. And over here, it's safe to assume that session storage is present because that's what my target device is or target storage provider is. And I can do all the low-level operations on storage, session storage here in this class and nowhere else. Only this class is aware that there's something called session storage and it just implements it. Likewise, I have a memory storage provider. Again, implements the storage provider. But this time, instead of relying on the session storage, it has an internal map that stores the key value pairs, like even session storage does. And as long as it implements these 4 methods, as long as it conforms to the interface of storage provider, I'm good. I'd just like to show you that I have used the ability of having private modifiers in TypeScript to my advantage here, because I would want this memory storage provider to have only one instance, and this is an implementation of the singleton pattern. So I have an instance reference to an instance that will return the memory storage provider instance the first time I invoke it, and every time afterwards I'll just return that instance. So I can only have one single instance of this memory storage provider because it's important, because I'll only be reading to and fro this single storage map. Alright, so we have two implementations of the provider. I will also show you something that I haven't shown you before, but now is the right time to do it. And this is something that's called a mixin. It looks a bit complicated, so do not go too deeply into it. But what this does is, I'm using a lesser known feature of ES6 classes that TypeScript really uses to its advantage here, which extends a given class and adds some properties to it. Okay? Just understand that. Do not get bogged down too much into details. What I'm doing here is, I'm doing that thing, I'm returning a mixin that implements a serializable interface that we defined before, and I'm inside that because I have to implement it too. So I have provided one implementation of what serializer could look like, and here is where I've said JSON.stringify. Similarly, I'm doing the JSON.parse on a deserialized function. Again, a mixin. I'll show you how this comes together. It comes together in my application here. I have the player controller, the new smart player controller, which does not know anything about its world. I'm mixing in the serializer and the deserializers to it. These are basically higher order functions that add value to my base class and they keep on adding to that. So, for instance, if I ever, if I were able to instantiate this with something, say null, I don't know, even null is no longer possible. I just can't get past the type system. I'll show you that later. Okay, so you understand what this does?
What is that mixin? What that indicates? Like why we have used that mixin as isn't that as a class? It's a simple class. We are implementing from. We are extending one class and then we are implementing from other.
Okay, so when you talk about implementing, you're talking about